So you see problem 1, force acceleration 1. And in force acceleration method, we draw the free body diagram and kinetic diagram. And free body diagram that you are very familiar with in statics. So the concept still apply in dynamics, more specifically it's kinetics. But for the kinetic diagrams, this is something new, and I'm going to show you for different scenarios with different time of motion, different time of body. And we have 6 scenario in here in problem 1. And the question is draw the kinetic diagram for the bodies shown below. Then the center of mass of each body is at the point G. And keep in mind, regardless of how you draw, the kinetic diagrams will have maximum 3 terms: MAGX, MAGY, and IG alpha. But depends on the motion, depends on the orientation of the motion. We may not use HEX, HEY. It can be parallel axis, perpendicular axis, normal axis, or parallel axis. So with that, let's show 2 different body in here. So the first body, we need to classify the motion in here. And you can see the body slide on the surface, horizontal surface. So with that, it's no rotation. So this body, it will be a translation. And translation through the x-axis. So if we have the x and y-axis, this body cannot jump up and down. So you don't have the acceleration in y direction. So you don't have MAY. It slides through the x. So you have MAGX. So first one, you can see here, you will have MAGX. MAGY, like I say, it not jump up and down for the body, so you don't have the acceleration in y direction. IG alpha, this body is not rotating, so you don't have the alpha angular acceleration, so you don't have IG alpha. So bottom line, maximum 3 term. In this body, it's only 1 term, MAGX. So it don't have to be all the kinetic diagram have 3 terms. It really depends on the type of motion, the body, how the body moves, etc. Then it will dictate how many terms you have for kinetic diagrams. So, but regardless, it's maximum 3 terms. So that one. Move to this one. On the right, this body rotate about A, and A is rotate about the axis perpendicular to screen and go through A. So that is a fixed axis. So as you can see, a body rotates about a fixed axis. The motion, it will be Rafa. So body about Rafa, you may not use MAGX, MAGY, and IG alpha as usual we do in kinetics diagrams for the general terms. Here you may use the tangential and normal components for the acceleration, because we know what is the equation for yours. So let's look here, and you can see Rafa rotate about A. Let's assume it rotate counterclockwise, so you will have IG alpha, right? IG alpha will go counterclockwise, first term. The second term, we will have tangential components. So you have, and it have to be consistent with the alpha, So alpha in here, we assume it counterclockwise. So MAG tangential component there, MAG. Instead of coed X, we have MAGT tangential component. We can put up here MAGT. And similarly for Rafa, acceleration have 2 components, tangential and normal tangential perpendicular to the radius, normal components parallel to the radius and point to the fixed axis. So you will have that one here. It will be MAG normal component. And why we use MAGT, MAGN instead of X and Y? Because we know AGT equal to alpha R. AGN equal to omega square R. So that's why we, for Rafa, we use tangential and normal components for the second finger in here. So as you can see, this is three terms in the second kinetic diagram. Move on to the next one. So let's assume this is a wheel and unbalanced wheel on the inclined surface. So when it inclined surface, as you can see, you normally assume that is the axis instead of xy. You will have a parallel and perpendicular. So let's do that here. It's rolling down. So you have the axis here. It's perpendicular and parallel to that motion. We have it parallel. So with that, and as you can see, when we draw the diagram, it at center of mass always. Remember, keep that in mind. So it's not at the center. You see unbalanced. So O is not the center of mass. G is the center of mass of the body. And we start to draw it in there. And when parallels, you will have, instead of MMGX, we have it MAG parallel. And then you have G, and you can see, go around and going down. So you actually G move up and down. So with that, we have another components in this case, because the imbalance wheel, you will have the MAG perpendicular. MAG perpendicular axis. And then, of course, the body is rotation, so GPM body. So that one is GPM, U1. So you also have a IG alpha. So there is three terms in this body: MAG parallel, MAG perpendicular, and IG alpha. So that is unbalanced wheel in inclined surface. The fourth, it will be the kinetic diagram for the wheel. In this case, it's a balanced wheel. The center of the wheel is also the center of mass. So with that, and the body rotate, so it both translate and rotation. So with that, we have this body also GPM. So GPM, let's talk about the three terms. MAGX, so here you can see it on the horizontal surface. So we can have that is the X and Y axis. So we have G moving. So we have that is MAGX. And then MAGY, and you can see, because this is a balanced wheel, unlike the unbalanced wheel that we just deal with on the left here, G keep moving horizontally parallel to the surface. So as you can see, G in the balance wheel, it will not move up and down because it's the center, it's always parallel to the surface. So they don't have the AGY component, it's zero. So as you can see, there will be no MAGY. And then because it's rotation, so we also have IG alpha. So as you can see, between the balanced wheel and unbalanced wheel, it's very different. If it's balanced wheel, only two terms, MAGX, MAG alpha. Go to the fifth one, kinetic diagram for this. As you can see, body BA will rotate about the axis perpendicular to string and go through B, so that it will be a Rafa body. And for Rafa, as you recall, we don't call it XY, but this one, similar to this, we have it MAGT and MAGN. So do exactly the same for the Rafa. Not about A, not about B. It will be at G. So you have one component here, it will be M, A, G, N, parallel to the radius. And then we have tangential components perpendicular to the radius, and that we call MAGT, tangential component. And this body rotation, so we also have IG alpha. So as you can see, the fifth diagram similar to the second diagram because it's Rafa. So we have MATX, MATT, MATN, and IG alpha. 3 terms, but not X and Y. Keep that in mind. So as you can see, X, Y, yes, but depends on the time of motion, the orientation of the motion, how the body is configured, that you can use different terms other than X and Y. So move to the last one, and as you can see, it don't need to be always 3 terms. The first one only 1. The fourth one here for the balance wheel only 2. Other 3. How about this? What type of motion for AB? A roller slide on the slot. B vertically, B horizontally, and the center of mass is G. And of course, this body is GPM, right? You can rotate and translate. So it will be GPM body. And yes, any random axis, so we can assume the X and Y axis, horizontal, vertical. So this is a general. So you can have, because GPM, so you have it M, A, G, X. G can move up or down, so you can have it M, A, G, Y. And AB also rotate. So we can have it IG alpha. So that really, the last one is the 3 term exactly on the general kinetic diagram that I showed you in the lesson notes. But other than that, as you can see, it don't have to be 3, depends on the diagram, depends on the motion, etc. So I can tell you that this problem very important. Many of the mistakes it come from the kinetic diagram. So have to review this many times so you can relate to the problem. Whenever a problem you face, you need to relate to this problem when you draw the kinetic diagram. So with that, we can apply Yo's concept for the next problem when we will have some calculations with the force acceleration method.